The name is Odorox. We oxidize odors, but the rest of the reaction is that we're looking after bacteria, virus, and mold species. And the difference between bacteria and virus is for energy consumption to destroy or neutralize that organism, very close. It's about here on a scale, but mold is way over here. And in typical UV units, probably 8 to 14,000 to destroy bacteria and virus. To destroy mold is 330,000. And that's why we tested the apex, which is the hardest to kill, which is the Aspergillus niger, commonly known as black mold.
Yes, in 1997 and 98, my wife had cancer. And she'd been through a few cancers already. And over the period of 25 years, she had 26 surgeries, so her recovery she was always in the hospital. So she was catching all sorts of infections. And I knew that in the hospital they were using ultraviolet for disinfection with their utensils and different things. So I started looking into ultraviolet or some sort of technology that would actually clean the air in a home without sprays or chemicals. But UV would be able to really sterilize the environment that she was in, and it would keep her alive longer. So that's what I had in mind. I bent the first piece of metal, bent it all up, made a little square box out of it, riveted it together, put the optics in there and the ballasts, and got it working. And the lamps are made of quartz. And you have different quartz and different clarity of quartz. It's a lot like diamonds. And so I learned so much. And then I was able to formulate my own formula. And then I would test it. And all of a sudden I have really wonderful results. And the results got better and better until we had the recipe all figured out.
In the year was 1998. And I had moved with my family to Kelowna, and had run into a friend of mine that I had not seen for several years. And we had worked in an industry together with 3M. And he told me that he had run into an individual that had quite a fascinating technology. And because I was already in medical sciences, I should perhaps take a look at it. It looked very interesting, but that's all he knew about it. He knew that devices were for real, and he was providing the decals for them. And I said, sure, do you have information? He said, all I have is this one brochure, please have a look. And it just took my imagination right away. And so I went into CGI and had my resume ready. I already had work. I worked in a medical office for almost 20 years as a researcher, and biomechanical engineering and sports medicine. So I already had a career. And I wasn't really looking for something else. But when I saw this, it was very imaginative and looked like it could be a very new frontier. I said, well, how do I become part of the organization? And he said, well, you could buy a distributorship. And I went, how much? And I had a check to him in a week's time. And that's how we started on a 12-year career together.
I remember at the time I was down to our last, we had money that we were going to buy this other house with. And I remember my wife telling me, she said, no, you go ahead. You just spend the money. I said, well, here's your last chance to get a new house. And she said, no, it's okay. This is going to work. I can smell it. I can feel it. So I pushed it. And then the next box got to be a little better. Then I was able to take it down to a sheet metal place. Showed the guy basically what I wanted. And then they got nicer and more effective.
The city of Kelowna, being quite a lovely city and well placed in the mountains, did not have a CNC machine which could automatically bend and cut and do all the things that were necessary for a sophisticated piece of material. So we had a local metal vendor hand make them for us to a point, and then we would do the assembly at our factory. At that time, though, it was in Guy's home, so we progressed from the garage to the downstairs, which was a very nice office, by the way. It was nicely carpeted and looked very professional. But in our first year, to our credit, we did $1 million worth of business.
Think about the days when we didn't wash our clothes and dry them in dryers. We washed them and hung them out on lines in the sunlight and brought that laundry in, and that wonderful, fresh, crisp smell of freshly dried linens and clothes we lose those in a dryer. When I brought my HGI hydroxyl generating unit home to try it out because I really believe in this technology, I began to feel that and sense that freshness again in the fabrics of my sofas and my drapes. And what it reminded me of was a fresh load of laundry in my house.
The discovery of the atmospheric hydroxyl was because of a new word that was coined into our the vernacular, which was acid rain. You might even have to reach back and say, I remember that word. How long ago did we hear that? The British were the first to really research it, and it was Leeds University was commissioned by the British government to have a look at that, how much coal dust was coming up, how much sulfuric acid was produced in acid rain, and what came down. And what they found was that what was going up wasn't equating to what should be coming down. In other words, there was a huge portion of it that was absent. So it's called a chemical sink. So it was sinking into something. What was taking it apart? They discovered that it was in the action of a hitherto unknown atmospheric agent, and it was called hydroxyl. And they were quite mesmerized by that, and they did chemical breakdowns for a lot of it, and how it would break up VOCs, natural and man-made, into the environment. But they couldn't replicate it. They did analyze it and continue to do so, and we do engage them from time to time on research matters. Where it fell to next to try to commercialize this was Penn State. Dr. Kowalski's lab had a look at that, and for quite a number of years we're trying to sequence what would be necessary, as the sun does, to create atmospheric hydroxyls. And they were at it for quite some time and could not quite get it just where it needed to be. So we were the next ones to really take up the mantle of the baton at that time and worked out how the sequencing had to be so that we could produce commercial amounts. Other people have hydroxyl generators where they generate passive amounts, but they weren't commercially viable. In other words, you couldn't do a sewage plant, a wastewater plant, a rendering facility, the types of things that would really bother a community beyond the fence line of that particular factory. And that's where we really wanted to be.
We've evolved over millions of years, plants, animals, and humans, to thrive in an environment saturated with natural hydroxyls. They kill the bacteria, viruses, mold and mildew, pollen, and other organic materials that accumulate even under natural conditions in our environment, that were they not checked and destroyed, the natural environment we live in would be out of balance and would become toxic. That balance doesn't exist in our increasingly insulated and confined indoor spaces. And what HGI has been able to do is bring that capability indoors and afford you that option to recreate that natural, fresh air quality, that balance indoors. And without that, the outgassing from your carpets, from your fabric, every time you bring a garment from the dry cleaners, every time your house is cleaned with a whole array of all those sprays and chemicals, they accumulate. They are not good for you. To breathe in hypochlorite from the bleach, if you use that as a cleaning solution, is actually very dangerous to your health. Hydroxyls indoors would decompose those and restore that natural balance and safety of your air. It also will get rid of the accumulated mold, mildew, bacteria that are a consequence of recycling your own air.
Actually came from a couple of employees that came to HGI, told me about what was going on there, explaining a little bit about the technology. In December of 2008, excuse me, I was asked to actually take a look at automating some of the hydroxyl generators at that point in time. I came in kind of to the facilities to really go through what they had at the time. I'm going to say I was a little leery, but I did a little, kind of background on checking out what a hydroxyl was. I heard some testimonials from the people that I know, but it really wasn't until I went down to, to a rendering plant and saw this technology working. And truly, if you've ever been to a rendering plant and how nasty that environment is, looking at this just rotting food in these pits and things like that, and looking at it, and it's kind of a mind game that you're not smelling anything. You're not seeing the flies. You're not seeing the maggots. You're not seeing what you would think, and you're just looking at this thing straight. I'd have to say, once anybody goes down to an environment like this, especially if they've been to an environment where this technology wasn't working, would make you a believer right there and then.
In the marketplace, there's a variety of sensors. Most of them are electrochemical sensors that are used to measure a variety of gases, both inert and corrosive. These devices were never designed to measure necessarily potent oxidizers with electrochemical potentials over 1 electron volt selectively. So when they respond to oxidizers, they respond to them as a group. So they'll routinely register positive for not only hydroxyls and ozone together, but hydrogen peroxide and hypochlorites, bleach, and lemon juice and other common oxidizers. It's not to criticize them as devices, it's just that their use is being inappropriately used in trying to selectively measure either ozone or hydroxyls. HGI commissioned an independent survey by Sanexen Environmental and Toxicology Services, a company that is extremely experienced in the use of hydroxyls in the sanitization process, and they surveyed vendors of these devices and laboratories that use other analytical methods. And in their report to the company, they said there are no commercially available labs or methods that can differentiate between a hydroxyl and ozone. And so HGI is taking it upon itself to develop new analytical methods to do just that.
The automation includes really a closed-loop environment. It actually is sampling the environment and making adjustments to accommodate the VOCs or the particulates that are in the environment. It's adaptively going into that. It's allowing you also to integrate it into a full manufacturing line or an environment where you need to be able to predict what's occurring. In other words, especially as we got moved from more of the odor into the bacteria kills in environments, the lines are now starting to depend on us to do their sanitation as opposed to utilizing chemicals. And once you do that, the reliability needs to be increased, being able to self-diagnose, self-correct, and to ensure that you're producing the proper amount of hydroxyls based on the production levels. So in other words, we'd be tying into a particular automation system, into the particular customer's automation system, and being able to predict based on what's coming down the line that we should be ramping up or ramping down our hydroxyl production in order to ensure that we're getting the right coverage.
It's a product that's as diversified in what it does as the applications that we can use it in and installations that we can do.
A German philosopher said that any basic truth is first ridiculed, is disbelieved, and then it's taken as self-evident. We're somewhere between 2 and 3. That we are doing this is a gargantuan task, and we're filtering out the information bit by bit.
As long as we stay focused in the market and we actually go and put all the science and backing up the claims, yeah, the future's bright.